no mixed numbers. Okay? Yes. So I want to point out a couple things. I want to point out the fact that before Easter break, we already dealt with some positive and negative integer rules. We're going to review those real quickly. And you pretty much did a lot of multiplying of fractions last year in 6th grade, right? So would you say we're learning anything brand spanking new today? No, okay? So we're going to take a couple notes, and then we'll do some problems on the whiteboard. So just stay with me. So the first thing I want you to remember is, remember we did our bell work? Well, I don't know. We didn't do our bell work today, but this was the first problem, right? And it said, change that to an addition problem. Did you make it negative 11 instead of subtracting a positive 5? You added a? And then when you did that answer, what did you do? You made it a? Good. You made it a negative 16. But today we're multiplying with integers, and that gives you a whole different answer. What if I had a negative 11 times a negative 5? That would be a what? Positive 55. Okay. Shh. So the most important thing today to know is that when the signs are the same, it's positive, right? What if that 11 was positive, but that 5 was negative? It would be negative 55. And what's one more way to get an answer of negative 55? Instead of what, Wesley?
Positive 11 and negative 5.
Yes, the 11 could be positive and the 5 could be negative. So I want to say a couple things about multiplication. Multiplication is way easier in every way than addition is. Because think about it. We just added mixed numbers. If I asked you to add 3.5 plus 2 1/3, I couldn't add it until those were both 6s. And it was kind of a pain in the butt, and then I had to find common denominators and blah, blah, blah. You don't have to find a common denominator for multiplication, right? You can just multiply, okay? With integers. Sometimes it said add, sometimes I really subtracted, sometimes it was positive, the sign of the larger number. Rubbish. It's crazy, right? So it's going to get easier with these negatives, okay? Did you have a question?
If the 11 is bigger than 5, wouldn't it be positive?
Great. I'm glad she asked that, because the answer is no. That's what I was just talking about. With multiplication, it does not matter what sign is bigger. That's only an addition rule. So let's do this, guys. If I multiply a negative times a negative, I will get a positive every single time. If one is negative and the other is positive, it will be negative every single time, guys. It does not matter which one's bigger. It'll be negative every single time. Even if the positive comes first and the negative second, yes. So cool. That's a nice little reminder. Another way to write this, you'll see sometimes people do it this way. Negative times negative, positive. Negative times positive, negative, or positive times negative is negative. Okay? All right. So I need to apply those rules to the fractions. So are we ready to jump into the fraction part of it? Okay? So let's do these like video games. We always talk about that, right? So level 1 is like a video game level that's really easy to beat. Everybody can do it. Your little brother or sister can beat it and be just fine with it, right? Okay? So let's talk about a level 1. A level 1 looks like this. Negative 1/3 times positive 2/5. Okay? And that's a level 1 because it's easy. There's not a whole lot of thinking to do. The first thing I need you to remember is that finally you can just multiply straight across and multiply straight across the top and bottom. I don't need to make it a 15. I don't need to do any canceling. I just do 1 times 2. Now watch for a second. I'm going to ignore this negative for a second, okay? Okay, this is my advice to you when you're dealing with negative fractions. Watch. Pretend like it's not there. What negative? I don't see a negative. 1 times 2 is 2, and 3 times 5 is 15, okay? Then I go back, and I figure out if my answer is positive or negative when I'm done. Well, this whole 1/3 is negative, and this whole 2/5 is positive. Not just the 1, okay? And what's a positive times a negative? Boom. So I kind of do the negative after I do the problem. I'm telling you, it's just going to be way easier that way, okay? All right, so let's have you try this level 1. Ready? So now you're going to try this on your whiteboard. You may take up your marker and do this problem. Raise it up when you're done. Level 1, nothing hard about it. Raise it when you have your answer.
You want it reduced?
Always reduced. Good. 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 Good, baby. No. Good. Not negative. Yes, good, Justin. Not a 10. Good. Some of you are still thinking adding. Good. Not negative, Josh. Is that positive, Jack? Yes. Okay. No cross-canceling. What's negative 5 times negative 5? Positive 25. And then 6 times 7? 42. Or you could look at it as, what's 5 times 5? 25. What's a negative times a negative? Positive. Okay? So now, on your boards, I want you to come up with a level 1 problem. Making it level 1 means no reducing, no cross-canceling, just that problem. So write it on your board and show me.
Like, so a super simple.
Yes, fine. Okay, grab one in that little thing right there. You'll see it. Look up on this board. It's attached to the... Right there. Yep. 7 and 10, 2 and 5. That works. That one works. Good. Good. 2 and 12 would reduce, though. I don't want it to be that reducing. 2 and 4 would reduce. Okay, good. Yep. Yeah. Okay, so a level 1 problem would look like this. I'll use yours. Negative 5/8 times 1/3. Now, if she had a 2/3 here, that would be, I got some cross-canceling to do, which we're going to talk about next. So this answer is seriously just negative 5/24. Ready for level 2? We all beat level 1? Okay. So now you're picking up your pencil, putting your lid on your marker. So level 2, ready? You'll get your marker back out in a minute. Looks like this. 2/3 times 3/5. Go ahead and try that for me. See what you get. Okay. So what did we do here? Do it on your whiteboard. Show me your answer on your whiteboard.
Actually, put it on my white piece of paper.
Yes, good. Reduce it, Naya. Okay, it's got to be reduced. All right, so every answer. Let's talk about this. All right, I'm seeing about half and half. All right, we have to talk about something here. Ready? Shh. Markers down. Lids on. Watch. If you just went, this is a little bit harder, guys. I told you it was a level 2, so you had to know there was something else to do other than just multiply 2 times 3 and 3 times 5. That's good, but there's a couple things to do, so watch. Many people look at this, even my advanced 8th grade high school algebra kids, and forget to reduce this one. Here's why. They look and they think that 15 is odd, so there's no way I can divide it by 2, and then they just assume that it's done. How about 3? Could I divide each of these by 3? Yes. And get what? 2/5. Okay? Did anybody do it differently, though? Jana? Yes. Shh. So we need to talk about this cross-canceling business. Now, are you ready for this? Some people, obviously a lot of you, because about half of you kept 6/15 as your answer, which tells me that maybe reducing is not a strong suit, or maybe it's not obvious to you when to reduce. So here's my advice to you. You're going to have to reduce somewhere. You're either going to reduce the answer or the problem. Reducing the problem means cross-canceling. And when you look at the diagonals, remember this, guys, from last year? If your diagonals are the same, the GCF is 3, and 3 goes into 3 once and into 3 once. So please watch. This is really the new, by cross-canceling, what you're doing is creating a new, better version, a smaller version of the problem. Wouldn't you always rather work with smaller numbers? Yeah. So wouldn't you rather do 2/1 times 1/5 instead of that? So that's what reducing does. It like shrinks your problem down to more manageable numbers. Okay? So look, what's 2 times 1? 2. 1 times 5. So look, that was way easier to do than reducing 6/15, wasn't it? Try this one. Ready? On your whiteboard. Go ahead. So we're going to do -4/5 times 5/7. This should be a piece of cake. Good. Yes. I got your negative right, Avery. Guys, got to slow down. Check your negatives. Good. No, reduce it. Cross cancel. Yes. Good. Cross cancel those 5s, Frank. Good. First thing you're going to do is check that. Okay, thanks. Negative, Josh. And 7. Okay, eyes up front. Shh. So when I look and see that both of these are 5s, the GCF is 5. 5 divided by itself is 1. All you have left is 4 times 1, 1 times 7, and a negative times a positive is a negative. Okay? Ready for level 3? Okay. Level 3 takes it a little trickier. So it still has let's say 6/7 times 7. Let's make it a negative. Let's make this a negative. There. Try that. You can do it on your whiteboard. Not negative. Reduce. Yes, Wesley, you got it. Yes. No, Eric. What is a negative times a negative, people? A positive. Take that little thing and erase that negative on there then. Good, Bailey. Good, Avery. Good. You can. Yes. Let's talk about this, guys. Shh. Okay, reduce it, Brooke. So, why is this called a level 3? Okay, watch. I canceled those 7s out. Then there were people, enough, who went right ahead and just then assumed that they should just multiply. 6 times 1 and 1 times 8. I like that, but you missed something. You should never hold that up to me because that is not reduced. Every answer from this point out ever should always be reduced. So if you didn't feel like cross-canceling, okay, then I guess you just have to reduce your answer. But some of you are not doing it either place. You either have to do your answer or the problem. You can't do neither. I kind of felt like reducing the problem was a little easier. So watch up here. Did anybody look at 6 and 8 and say, what number goes into both 6 and 8? 2. How many times can 2 fit into 6?
3.
And into 8?
4.
And that's where your 3/4 comes from. And negative times negative is positive. Try this one. Okay? 10/12 times negative 3/10. Okay, you have a couple options here. What's that? Yes, you can do it on the whiteboard. Good. Good, Avery. Not quite, Bailey. You reduced it wrong, I think. Good. No, you redid it right. You just got to reduce it correctly. Yes, Bailey, you got it now. No, Eric, reduce it. Good. Good. Good, Ian. Reduce it now. Yes. No, Ryan, yes. You two back there. Yes. Yes. Ryan was good. No, Ryan was not. Those two are good. Okay. All right. We have a couple different options here. I would totally do it this way, though. I would just do this. And those become ones. And then I think some people then just multiplied straight across and made it 3/12. Okay? But you can't leave it 3/12, right? Plus it's negative. You have to reduce it by 3, which means 1/4. Did anybody reduce more on the problem? Did you just say 3/12 reduces to 1/4 there? And then did 1 times 1 and 4 times 1 and you totally skipped that step? So it's kind of like you got to do it somewhere, right? Okay? How about, I'm looking for this particular problem. And let me talk to you about why cross-canceling is important. My son, who is 20 now, when he was in 6th grade, I don't know what grade it was, 5th grade, 6th grade, he just never wanted to cross-cancel. He said, I don't know how to do it. It's a pain in the butt. I'm just going to always multiply and then reduce. Well, eventually the problems got too big to reduce. So I said, all right, Sebastian, you don't want to cross-cancel. Fine, do this problem. Not you. This was the problem I gave him. And I was like, go ahead and do 24 times 48 and get that. And then do 56 times 52 and then get that. Then reduce that big fat answer. He was like, okay, teach me how to cross-cancel. I'll do it. Okay, so obviously cross-canceling is your best option. You should always try to reduce the problem before the answer, okay? So I have kind of another problem here, and I really kind of want to see who catches it. All right, so we're going to make this our level 4. We're moving up. Level 4s are starting to get kind of tricky, right? You can do it on the whiteboard. All right. All right. You have a couple options. Nobody has seen this other way here today. Actually, one person did it this way. Reduce it. Positive or negative? Mm-hmm.
So what problems you give us, we have to write it down.
Yeah. Well, I mean, I'm letting you do it on your whiteboard right now. That's fine. No, in the back is. That's good. Mm-hmm. Yes. Yes. Wait, what do you have, Eric, on the bottom? No. Yes. Yes, Shaden. Good, Ryan. Reduce. Yes. Yes. I can't see that, Justin. That is so small. Yes, Ian, you're good. Reduce it. Yeah.
Could you borrow some of your peppermint?
Not right now. Just one. Okay, so really quick, let's look up here. How many of you reduced the 5 and the 10? Okay, so you said the GCF of 5 and 10, meaning the biggest number I can fit into both is 5. And 5 fits in there once and in here twice. So then you did -3 times 2 and got -6. And then 1 times 20 is 20. Some of you left it, but you have to reduce that more. So here's the deal. Sometimes when you reduce the problem, you still end up having to reduce the answer. That's just the way it works. The answer is -3/10. Does anybody see another way to do this problem? Yes. Starting with a fresh -3/5 and 10/20. 10/20 is really what, Ryan? Yes. So watch what I'm about to do. People always think, eyes up here, not on the board right now, that the canceling has to take place diagonally like this. Well, yeah. 10/20 is a fraction that's equal to 1/2. So what do I get if I multiply -3/5 times 1/2? -3/10. Okay? Frank, put the lid on that marker. That's a new one. That's going to wear out. So could you, like if you have 5/10 or 20/40 or 3/6 or 4/8, could you reduce that and then multiply it? Absolutely. So I want you to try this problem. -4/9 times -6/12. And you have to decide which route you're going to go. So which route are you going to go? Good. Yep. This one's taking a little longer because you got lots of options. No. No, Justin. Yes. No. Reduce that. Good. Good. Good, Izzy. No. Yes. Let me see. What do you have, Angel? No. Good. Both of you. Yep. Good. Okay. Reduce it. Cut each in half right now. Divide each by 2. Okay, guys. Did anybody take their 6/12 and just make it a half? So you did 4/9 times 1/2. Then some people did not look to see if they could do more. Could you do more? 1 and stop with the gosh. It's just stop the noise. 2 times 1 and 9 times 1. Or did anybody just not make it a half? Did you just say 3 goes into 6 and 9? How many times does 3 go in here? And in here? 4/12 is the same as 1/3. And do you see where your 2 9s comes from now? 1 times 2 and 3 times 3. 2 9s. Got it? Okay, let's try another one. Ready? 4/6 times -2 9. Positive or negative? You're going so fast you're forgetting the negatives, and you're going to get a whole bunch wrong on your test because you're so worried about getting it done first instead of taking your time. It's a negative. What's a positive times a negative? Good. Good, Brooke. Yes. Good. 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 2 goes into itself once and into 6 3 times. Negative. 4 times 1 is 4. 3 times 9 is 27. And what's a positive times a negative? Think you got it? Okay. So I want you to create your own problem and show it to me. The one I like the most, I'll have the class do. I want you to have to do a double cross cancel. I want these to cross cancel and these to cross cancel. Set it up so that would cross cancel. And I'll pick my favorite. Make it so that they both will cross cancel. Good. That's a good one. I'll be even happier if it has a negative in it. Or 2. There we go. Would the answer be the same?
No.
It would, yeah. Mm-hmm. Good. Okay, now find the answer out to the problem that you just did. Good, Eric. 3 and 4 won't cross cancel. I want them both to do a cross canceling. 46, 23, half and a half. Yep, good. Good. Okay. Good. Yes, look at right in the little thing there. 3 and 9, 8 and 4. Yeah, if it's not working. 8 tenths, 4 12. Is that a 16? Yeah. Okay, all right, I'm going to use Angel's problem. Ready? Negative 8 tenths times what? 4 twelfths? Okay. 4 twelfths. Oh, you have so many options of how you can do this. Go ahead. I'm just curious to see how you would do it, because the options are endless here. What do those little arrows mean? Here's your task. If you know that I'm talking about that there are 2 ways to do it both ways. See if you get the same answer. By both ways, I mean reduce 8 tenths, reduce 4 twelfths, and multiply those. And see if you get the same answer. I didn't do it yet, but. Good. You got it. Yeah? Positive or negative? Yes, negative. Good. Good problem. Yes. Okay, I do notice it's the same people holding up their boards, but watch. Did anybody reduce negative 8 tenths to negative 4 fifths? Yes. And then 4 twelfths is 1/3? Yes. And then that is negative 4 15ths? Okay, another way to do it would be 4 and 10. This is 2 fifths, right? 8 goes into 12, or 4 goes into both. And then there's your 4 15ths negative. Okay, no homework. Go ahead and just leave. Actually, we're going to pass up the markers. Do your best. I'll have a couple helpers stay back and help me. I'll stay back and keep the markers. It's